Hello, dear conference participants. Our topic is the study of photovoltaic properties of solar cells and sensors based on the semiconductor heterostructure of the p-cadmium tellurium and cadmium DS, and p-cadmium tellurium and cadmium selen. The article examines the effect of temperature on the rate of surface recombination of solar cells and sensors based on film heterostructures of p-cadmium tellurium and cadmium selen, and p-cadmium tellurium and n-cadmium selen films. It is established that the rates of surface recombination S on the heterosurface at an S to the infinity tend not to infinity but to affinity drift velocity in the Brunel electric field. It is shown that carrier separation occurs not at the interface between cadmiums and cadmium tellurium, but at depth of the cadmium tellurium layer equal to several micrometers from the surface, which associated with the formation of layer as a result of the diffusion of a free cadmium atom into a p-cadmium tellurium. It was found that the created optical sensors with a single software control are suitable for the use of microcontrollers in wide ranges of the ER range. By increasing the temperature of the optical sensors, uniformity of sensitivity and significant reduction in the influences of background signals are achieved. It is shown that using an optical sensors it is possible to determine the dustiness and smoke content of indoor and outdoor air. In this photodetector, the photodetectors obtained on the basis of p-cadmium tellurium and cadmium selen heteroadjustment have low efficiency, which is due to the complexity of allowing cadmium selen layers as the appearance of a trip compound in the transition region due to the neutral solubility of the cadmium tellur and cadmium selen. In this paper, we selected elements of the first group such as Ag and cuprium as alloying additives for cadmium tellurium films. The following factors determined the choice of these metals as alloying additives. Comparatively low values of the optimal Ag and cupriums allowing the temperature in the cadmium tellurium range from 80 to 300 degrees Celsius on the subdated scale. To obtain cadmium tellurium films, this maximum photosensitivity and stable parameters, certain conditions must be met. In addition, these impurities play a key role of eliminating surface defects and have a significant effect of the interface between crystals. Optimization of intercrystalline barriers, including maintaining maximum photosensitivity and adjusting crystal sizes. To create an optical heterostructure, the parameters of time is T, decrease is D, and photoposition rate Vk of the material where positivity determined. The volt-ampere characteristic is further interrogated as the temperature increases as the length of the drape section increases as shown in the figure 1, and the section of the sharp increases its current shortens. In addition, the current value at high temperatures in the square section is less than its value at room temperature, AI at content voltage. The current decreases with this increase in temperature. This behavior of the volt-ampere characteristic clearly indicates the mode of current limited by spell charges. The level of air pollution is determined using special optical sensors equipped with a base at the salt hole in the middle located on the lower and upper sides of the structure. Inside the device for measuring air quality is an LED that emits light waves with the directed salt and optical systems and interacts with the surface and the pollution particles with shown in the figure 2. Inside the opposite wall of the sensor in the mirror that reflects solar rays that do not reach their target. So, an LED emits many rays that collected these particles of polluted air, then these rays reflected from them pass through the lenses and hit the surfaces of a photodetector based on the heteroconductivity of the p-cadmium tellurium and cadmium selen and the p-cadmium tellurium and cadmium selen. This conductivity of clean air, the light flux from the source passes directivity through the reflector mirror to the photodetector, while the backlighted in absorbed by the reflective elements where they act as light traps, forwarding almost a complete blocking of the unwanted signal from the inflated LED and external light.
Поглощается отражающимся элементами, или они действуют как световые ложки, обеспечивая практически полное блокирование нежелательного сигнала от инфракрасного светодиода внешнего освещения.
The production of semiconductor sensors using heterostructural photodetectors based on the p-cadmium tellurium and cadmium S and p-cadmium tellurium and cadmium selenide for air pollution monitoring is carried out as follows. The device body is made of plastic and protection from electromagnetic fields is provided by a metal cover. The case contains semiconductor components, an infrared LED circuit control unit and amplification circuit, and a glass mirror for detecting the infrared beam. The optical sensors, weighing only 17 grams, has minimal dimensions due to the use of the new components such as heterostructures, photodetector, and reflective mirror, which allows it to be placed even in the most inaccessible places. To measure the level of air pollution, a new sensor based on the heterostructure of p-cadmium tellurium and cadmium S and p-cadmium tellurium and cadmium selenide was developed, while a reflectivity mirror used for the first time in the signal and a pair of lenses. Only 2 of the 6 contacts are required to interact with the sensor. The device for collecting polluting particles and gas used radial ribs from the particulation plate, which are inside the end section located at the base of the hole, forming direct channels for the passage of gases and pollution particles. The new sensors equipped with p-cadmium tellurium and cadmium S and p-cadmium tellurium and cadmium selenide heterojunction photodetectors are used to detect pollutants in the air and have a special design with the central hole of the base as well as on the inner and outer surfaces. An ER LED is installed inside the sensors, which detects direct rays inside the lens to the particles of polluted air. A detector for measuring the degree of atmospheric pollution has also been developed, characterized by the use of a new heterostructure photodetector based on the p-cadmium tellurium and cadmium S and p-cadmium tellurium and cadmium selenide. This is deeply located and polluted. This provided high gas operation efficiency compared to a standard silicon photodiode due to the presence of a reflective mirror capable of reflecting up to 90% of lighting and increases the intensity of infrared radiation in the work area. Thus, based on the experimental source obtained, it can be judged that temperature plays a significant role in the created heteroconductivity heterostructures and reduces the effect of surface recombination on photosensitivity in the range from 0.5 microns to 0.9 microns of electromagnetic radiation. This such identification to the heterostructures, the created sensors based on the cadmium tellurium heterojunction have a number of the advanced existing detectors. First, the heteroconduction detector passes in a wide spectral range covering the near-infrared region, corresponding to photon energies from 0.5, 0.4 to 3.0 electron volts. Second, the addition of silver dopant helps to amplify the signals and increases the current. Third, the addition of silver leads to an increase in photosensitivity, which manifestations in area of ambiguity absorption. Thus, these heteroconductors can be used to determine the degree of smoke and air pollution. Thanks for attention. I will finish my part.
Спасибо за внимание. Я закончил свой доклад.